Sound is a form of vibration that travels through the air as waves. Analog data is the type of data we, as humans, understand. In order for computers to represent and encode sound, we need to convert these analog waves into digital data. The process of converting analog sound waves into digital data is called sampling. Sampling involves measuring the amplitude, that is the height of a sound wave, at regular time intervals. Each sample has a unique binary value. The sampling rate determines how often these samples are taken. It's measured in hertz and represents the number of samples taken per second. For example, 44.1 kHz means that 44,100 samples are taken per second. The higher the sampling rate, the better the sound quality, as more samples would mean the digital sound wave is closer to the analog sound wave. Meanwhile, sampling resolution refers to the number of bits used to represent each sample. The higher the sampling resolution, the greater the sound quality. Changing the sampling rate and resolution can significantly impact the quality and file size of digital sound file. A higher sampling rate increases file size and sound accuracy, as more samples are taken per second. Similarly, a higher sampling resolution increases file size and sound accuracy, as each sample stores more bits and hence accurate data.